topic, mid-segments. I came up with these four pictures which I think really depict what is going on in the world of the internet with regards to mid-segments. This first one is kind of an artistic rendering of a transformer. Before all the special effects and everything is put on it, they actually make a computer animation piece of this, and each one of these yellow pieces is something that can have contact or can have something attached to it or whatever else. And it's about midway through or about halfway through their artist rendering. So they will actually put more color on this. They'll put more shadows and everything on this. They might put some extra armor or something on it, but it's not quite done. It's about halfway done. They actually don't have all the facial features or some of the other muscle types or whatever. This is part way through. This is apparently some sort of Gundam. I'm not sure what that means, but it was on the internet, so I figured that would be kind of cool. This is a mid-segment vehicle. It's a hatchback. That means it's about halfway up the chain of like really cheap cars or really expensive cars. It's about halfway in between. It's kind of a cool hatchback, I guess. Mid-level vehicle is kind of how we talk about it here in the United States. This is a dog on ice. I'm not really sure what it has to do with mid-segments, but when I ran a search, that was one of the things that came up. Sometimes I feel like this dog, just that I need to, hang out for a little while and just cool off from, I don't know what's going on, but that's kind of a dog on ice. And here's the mid-segment of a triangle. The mid-segment of a triangle, obviously what we're going to look at today, what we're going to do is we're going to take the midpoint of one side and the midpoint of another side. We're actually going to connect those two pieces, and we're going to see some of the interesting properties that come out from the mid-segment. So this is called the mid-segment. You have a piece of paper in front of you where you're going to actually do an investigation. It says using a ruler, measure each side in centimeters. So you'll measure this side in centimeters and this side in centimeters. You'll actually mark the midpoints of the left and the right side. You'll label them A and B respectively. You'll draw the mid-segment, kind of connecting A and B together. And then you'll actually record the lengths of AB and the length of RI. Take a minute and do this on your own. Okay, welcome back. I just got done measuring mine. I found out that the length of this side was somewhere about 7.4 inches. This was 7.4 inches. This bottom actually was also 7.4. So we're dealing with an equilateral triangle. When I found the midpoint here, I put A there. Found the midpoint of this side, I put B there. When I ended up measuring these, it turned out that this was 3.7. AB was 3.7, which is actually half the length of the 7.4, which is on the bottom. So 3.7, 7.4. If you measured it, hopefully you're going to be pretty close to that, 3.7 and 7.4. What also I thought was kind of interesting is this line segment ended up being parallel to this other line segment. So these two pieces here turned out to be parallel, which reminds me of the idea of a triangle. So if we kind of cut this whole part off here, we're kind of dealing with a trapezoid here on the bottom. And actually, apparently probably an isosceles trapezoid or some other type of trapezoid, since these guys are going to be parallel. Kind of an interesting idea. So the triangle mid-segment conjecture, here's what it says. It says that mid-segment of a triangle is parallel. So that segment that we drew is going to be parallel to the third side, and it's going to be half. It's going to be half or 1/2 the length of the third side. So that means when we deal with MP, I can say that MP is half of NO. Okay? So when I say this, what number is half of 16? Well, 8 is half of 16. In a similar fashion, if it gives me PM, I say that 7 is half of what number? Well, 7 is half of 14, so 14 goes on the line here. This part's 7, this is 14. This part's 8, this is 16. So you always say the mid-segment is half the third side. Next, we're going to do another investigation. We're going to use a ruler to measure the sides in centimeters. We're going to find the midpoints of these three sides. We're going to connect those into mid-segments and see what happens afterwards. Welcome back. I've just drawn my three sides here, these three midpoints and these mid-segments. And what happens with this is it looks like I have 1, 2, 3, 4 triangles, and they're all congruent. Let's take a quick look at this on the back side of the handout. It says the three mid-segments conjecture. That was a tough one. Actually, the three mid-segments of a triangle divide the triangle into four congruent triangles. And we're going to investigate some of the properties of these triangles here in just a second. It says that in triangle DEF, so DEF, the original triangle, we found out that, EG was going to be congruent to DG. So that was sort of how this became the midpoint, and we were able to draw this mid-segment. We knew that EJ was the same as FJ, so that's what made this the midpoint right here. J was the midpoint. And finally, DK was congruent to KF. So this K was the midpoint. So we were able to connect the three midpoints. We got this new triangle, and actually we got a total of 4 triangles. In this now we notice that GJ is actually parallel to this base. It's also the same length as this base as well. So this piece, and this piece are all the same length. So I'm going to write that down. GJ is parallel to DF. Make sure that you have a segment on top of there. And if we look at this DK, it's going to be the same length as KF. Is also going to be congruent to GJ. In a similar fashion, we can talk about these segments over here. JK right here is actually going to be parallel to this piece over here. So we can say to the segment DE, this entire left side of this piece. We also know that DG is going to be congruent to DG as well as JK. These are both segments. Okay? And finally, we could probably talk about this side over here. We'll put 3 arrows over here. Is going to be congruent to this part here. We'll put 3 arrows there. And it's also going to have 2 tick marks so that each one of these triangles has 1 tick mark, 2 tick marks, 3 tick marks. Here's 1 tick mark, 2 tick marks, 3 tick marks, 1, 2, and 3. And this one's kind of turned a little bit, but it does have 1, 2, and 3 tick marks. That leaves us with GK being parallel to segment EF. And finally, that EJ is going to be congruent to JF as well as GK. Okay, take a look at those. Make sure that makes sense. Basically, the concept here is, if I switch colors, is that this segment is going to be congruent to this segment over here, and also this third segment over here. They're also going to be parallel. And if I switch colors again, I can say that this segment is congruent to this segment, and also this segment. These 3 segments are all the same length, and they're both parallel to each other. If I can grab another color, I'll use this black. This segment right here is congruent to this bottom segment and this second bottom segment, and those are also parallel. Each of these triangles also now has a red, green, and black piece to it. Red, green, black, red, green, black, and then finally this one sort of flips. It's green, black, and red. Okay. Trapezoid mid-segment conjecture. It says the mid-segment of a trapezoid is parallel. It's going to be parallel to the bases and is equal in length to, this is kind of a weird thing, the average length of the bases. Okay? And there's going to be a little formula for this. That's why it says M equals. And basically, if we call the top base base 1 and the second base base 2, we'll just divide this by 2. So the average, if you have 2 things, you add them together, divide by 2. That's how you find the average. So the average of the bases, if I call this base 1 and this base 2, I'll add them together. And when I get this third piece in here, my mid-segment, if this was congruent, this would be base 1 plus base 2 divided by 2. So for example, if this was 10 and this was 30, 10 plus 30 is 40. 40 divided by 2 would make this 20. Another interesting characteristic of this, to get from 10 to 20, we add 10. To get from 20 to 30, we also add 10. It's kind of a shortcut way of trying to find these bases. Again, if this was 100 and this was 300, 100 plus 300 is 400. 400 divided by 2 is 200. To get from 100 to 200, I'm adding 100. To get from 200 to 300, I'm also adding 100. Kind of an interesting characteristic of these bases. Example number 4 says in the diagram, MN is the midsegment of this trapezoid. Find MD. So the idea here is I'm just going to add these two together. So 16 plus 9 is 25. I'll divide those by 2, and this midsegment should be 12.5. So this part's 12.5. So to get from 9 to 12.5, I'm going to add 3.5. And to get from 12.5 to 16, I'm going to add 3.5. Over here, if I know that one base is 30 and the other base is 12, I would have the average be 42 divided by 2, which would be 21. So this base is 21. To get from 12 to 21, I'm basically adding 9. To get from 21 up to 30, I'm also adding 9. If I was to make up another example, maybe with these two warriors here, this is again as the mid-segment warrior. This is kind of after they added some of the extra effects to them. If I have 35 and 28 and X, I know that 28 is my mid-segment. I could say 28 equals, that's going to be 35 plus X divided by 2. To solve this, I'm going to multiply both sides by 2, so that'd be 56 equals 35 plus X. I'll subtract 35 from both sides, and I'll get X equals 21. So this top case would be 21. To sort of check my work on this, to get from 21 to 28, I'd add 7. To get from 28 to 35, I'd also add 7. It's a good way for me to check to make sure that I did this right. So dealing with mid-segments, you can have mid-segments of triangles, and you can also have mid-segments of trapezoids. You can also have mid-segments in buildings, I guess. But as we go through, as we look at each of these pieces, we go back through and we notice some of the properties. I thought it was very interesting kind of looking through things that were on the internet, just as well as all these other items that we might have. My last slide actually shows a company somewhere in India that actually uses this mid-segment triangle as their symbol. They actually stack it a couple more times here, but all these triangles, these are actually mid-segments of triangles. Kind of ridiculous, but that's actually their symbol for, I don't know, whatever they use here in this city, New Gurgen.